LRVS. And without further ado, I'm going to bring on Dr. Abid in a little bit. He is going to be telling us all about some great things. So I'm going to get ready to bring him on the stage. And I know Assad is saying good morning. Good morning to you. Thank you for joining us. So let me bring Dr. Abid on the stage. Hi, good morning, Dr. Abid. He's gonna help us and he's gonna bring up his slides and start to present what he's talking about this morning. Because he is actually going to be talking about turbine oil monitoring and quality, how that leads to turbine reliability. So Dr. Abid is going to give us some
Okay,
good insights
good
into
morning and
that.
assalamu alaikum to everybody. You can hear me?
I can hear you very
Okay.
clearly.
And all the audience. Today we are going to present practical case. Actually, we are the first lubricant plant in the Kingdom of Saudi Arabia, which was inaugurated by late King Malik Faisal Marhum. And we are operating in the kingdom and we are producing a lot of lubricant. And one of the product is a turbine oil. We are holding maybe more than 60% volume of Kingdom of Saudi Arabia in the turbine oil segment. So this presentation, which examine in the next 20 minutes to 30 minutes, will monitor and analyzing on the condition through a systematic way that can help identify turbine problem before they result in a major failure. So what happened? We have in the central region one of the big power plant where we and the General Electric, whose turbine were exist there, and we were supplying the lubricant turbine oil BG32 grade. It is a practical case in year 2010 when we receive a set of samples from the site, and in this, the first lab report, you can see this all the test parameter were quite good, except the color is showing light green, which is sparked to us, and then we systematically investigated. So this presentation will only give the the outcome of that how we smartly investigated and we avoid any breakdown or big damage to the turbine. And we find what was the reason of this blue color. Initially, I think come that this bluish is due to copper or something, but there was no copper in the solution. You can see some of the internal part of that turbine, how it looks at that time. It is a mid of year 2010 in one of the biggest power plant in the central region. We did along with the General Electric, since all these data I'm presenting based on the trust, it is not patented or it is not property of our, but it is a joint things, and we achieve something at the end result. So I'm just sharing with the audience that how if we do a systematic analysis of a customer complaint, we can adapt with some beneficial thing. Here you can see the problem turbine receive gradual losses of pressure in the hydraulic system. They're all this valve get choked and some pressure issues come up. In this slide, you can see the supplied oil color, which is a new lube oil color. And at 7,000 hours, something like 10-month to 12-month operation, the oil turned to bluish. We have taken some of the high-tech analytical chemistry help to analyze those of the varnish or sludge particle, and root cause was contaminated gel. Gel is a hydrocarbon product formed due to the varnishing, and I will not go in the all this detail. You can have it in the slide pack form after this presentation. We are again the first company who are producing with the Group 3 base oil since 2006. We start importing the Group 3 base oil from S Oil, which were partly owned by Saudi Aramco at that time in year 2005 and 6. And now it is 100% owned by Saudi Aramco, which refinery is in Onsan port in South Korea. And we are the first producing the high level turbine oil within the Kingdom of Saudi Arabia since year 2006. In this presentation, actually, the main thing we are suggesting a corrective action, preventive action due to some unwanted issue which was happened. We have a total investigation 125 bullet point, but I just capture here 25. And out of that, again, the used oil monitoring and this interpretation is the key of this success story. One of the main thing in this subject was a bluish color. What we did, we were asked to help identify the cause of the problem. We had never had this problem except a case of a storm turbine, which was 400 megawatt for a steam turbine here in the western region, where we had blue issues in the turbine oil color, which I can show you at the end of the slide. But that blue was a different means reason of having the color of the oil. So in the last slide, we will just we analyze electro spray ionization mass spectrophotometer to analyze these fine particles, and also we help these study with the FTIR and Fourier transform nuclear magnetic resonance spectroscopy to characterize the structure elucidation of this organic compound which was formed inside the turbine due to the weak acid remaining. We have find that often the big equipment is being cleaned at a pre-commissioning stage or commissioning stage or at a hydro testing stage with a chemical cleaning. Often oxalic acid, succinic acid, or some other weak acid is being utilized. So we able to develop some compound in the lab, and this is the top two structure. You can see the what we able to understand. This Comasi brilliant blue dye is produced by Sigma Aldrich. The people who have a strong chemistry background, they know this is the dye available in the commercial market. So what had happened that due to that weak acid and some of the antioxidant in the oil which form the similar molecule which shows the blue color. Alkylated diphenylamine are commonly used as antioxidant because we were using a chemistry at that time based on Lubrizol different package, and we are able to you can see here the diphenylamine when react with the oxalic acid it produce some structure which was in the blue color. So we able to find the root cause through this dedicated study. And also we engage one of the company which is providing a very specific solution for the mechanical integrity is Aqil solution, deliver integrated solution product and services including root cause analysis. It is all mechanical. I am not involved in this thing, but since it's the whole study was two side. One is the chemical investigation where I was directly involved, and the mechanical investigation which was here you can see the problem station, the statement affected site has reported hydraulic pressure unit problem due to suspected issue with a sun cartridge valve. All these valve, these fine blue varnish particle were the reason of malfunctioning of this gadget. In conclusion, contamination was undoubtedly the source of failure of these hydraulic valve. Foreign contaminants restricted to the orifice and interfere with the flow mechanics prevent the valve from proper operation. Here, I would like to tell only one thing that it is a conventional base, but nowadays artificial intelligence came. Not similar issue, but we were also selling to the military for this oil. So I had remember maybe 15, 16 years before when we sold our hydraulic oil to one of the combined military forces in Tabuk area, Quwat Musalla, Saudi Arab, where they have a big simulator where our hydraulic oil were using. So these contaminants and these fine wear metal, which is a cleanliness level. When we supplied the oil to this turbine, it was a NAS 5, 6. And over the time when we receive after 10 months or 12 months the sample, the NAS was reached to 9 and 10. So we concluded that we need a short interval turbine oil monitoring, not like one has to wait for a long term. and then this deterioration happens. So in the combined military workshop where we have simulator, we find an instrument which broken and a small particle from the wear metal. One can also find this metal is from which source, which part, and it is from bearing, it is from shaft or something else. So nowadays the analytical technique is more far above, which can help in helping the instrument operation. See, we send our oil to a lab is called Focus Lab in Thailand, and each used oil report was 7 pages. I cannot show here all, but two of the this gas turbine number one and number two before filter sample shows that on the right upper side wear condition was cautious yellow and contamination was cautious, means the NAS level was increased from 5 to something like 7, 8, 9. And on the gas turbine number two, you can see here even the wear condition and the contamination was red. Red means you need to immediately shut down or you need to replace the oil. But oil condition remain in both cases green, means the physical parameter of the oil and the antioxidant remaining is in the fair form. In the old time, we were measuring the RBOT or RPBOT 2722, but nowadays, after thanks that we had this instrument from Flutech, I would like to thanks for Flutech for this seminar also, that we are now regularly monitoring our remaining antioxidant in our supply turbine oil for the sites, and we can gauge the situation in much advanced stage. This slide will show this greasy gooey type material from the turbine filters. You can see the left side is green and lube oil supplied was fairly color was less than zero point 0.5 as per ASTM 1500. This slide shows again some kind of means scanning electron microscope which we carried out in US for this study, which again proved that what happened in the oil due to some misoperation. And in the last second line, the resulting loss of power was primarily due to the deposition of the pigment and the insoluble salt ahead by the gel ability to allow the mixture to be entrapped on the valve pressure regulator orifice, stick on valve series and other surface, leading to system malfunction. We have also found that ill practices and non-compliance with procedure specific to GEK's reference mm, maintenance program was not unfortunately followed. So it was also the reason, which I mentioned earlier. The blue color was for means developed due to the weak acid and this antioxidant reaction, which we only prove that how this blue color achieve or is formed. So in conclusion, the turbine oil monitoring having a three part. Oil conditioning is one part. Often people are doing only on this thing, viscosity, RPBOT, BI, tan demulsibility, forming air release value of flash point, core point, but oil cleanliness is a greatly affecting. In the last 2 decades, the research paper published on this one is saying that 85% malfunctioning of any big rotating equipment is due to the contamination or oil cleanliness, which can also be checked. The material wear is the third part, which is also monitoring is important. And healthy machine generate wear particle at an exponential rate. If the machine is operating in a normal, this linear relation, because the oil has a finite life, but it has a linear relation for the machine wear. But if something goes wrong, then exponentially wear start is rapidly as a parabola or hyperbola. So method of monitoring laboratory analysis, which we are doing in our Riyadh plant and Jeddah plant. We are operating three plant, by the way. One plant is in Jabal Ali, Dubai, one is in Jeddah, and one is in Riyadh. And we do have a mobile lab within the kingdom. One is in the eastern region, one is in the central region, one is in the western region, to support for the critical customer for all B2B who where our mobile lab having some instrument, and we immediately rush to the side where this problem, and then we send back the sample to our stationary lab. This is the one of the second last slide. You can see this is the Alstom, but I did not focus on this. Here again, you see on the left side, our oil was this. Is this is the story in year 2006 or 7. Our oil after certain maybe same 6,000 7,000 hours, it turned to bluish. When I visited with my team at that time, we find very immediately the culprit is this in the bucket type cartridge filter. These plastics or something which was on the filter, it was the reason of the blues. The blue color was leaching from there, and then we explained to the people from Alstom this turbine, and we addressed the issue because it is one of the reasons that total acid number in the turbine oil due to this antioxidant is sometime 0.1 0.15, so it might affect on the plastics. So it is a good input to the manufacturer also, and they have revised this specs of the cartridge. With this, I'm just presenting that with professional and dedicated used oil monitoring will enhance and will help to the everything. And not only the safety, it extended the equipment diet, reliability is greatly affected and saving the cost. So this is the takeaway point for the attendees. Proactive maintenance strategies can lead to significant long-term benefit. Employ both lab analysis and real-time monitoring can greatly enhance reliability. Regular monitoring of turbine oil is crucial for optimal performance. Thank you.
All right, Dr. Abid, well done. So I'm gonna remove this from the stage for a little bit and we could bring you all up because you had a very interesting PowerPoint presentation. Like the blue
I
was
don't know.
very,
I
the
don't know
blue,
if I manage in a time because you gave a 20-minute slot.
yeah, you're still within the time frame. You're still good to go. Good to go. But I saw that the while the blue was very pretty for me, I know it was a problem having that color in the oil. So we do have one question from Guillaume so far, and he's asking what frequency of sampling and full used oil analysis reports do you recommend? I mean, of course, based on your experience and your wisdom.
Based on my personal experience and based on at least more than 80 turbines we were operating in the last 19 years with this organization, I would say that first thing you need to collect the oil and you see with the naked eyes. If
Okay.
with the naked eyes everything is okay, at least you can collect sample with the naked eyes by monthly basis
Right.
only. And for monthly basis, you can do the basic analysis like viscosity,
Ah,
pour point, flash point, something simple. And for every 2 months, you can do this RPBOT, or nowadays antioxidant remaining
yes.
test is the critical parameter.
Mm-hmm.
And the cleanliness also, it can give you some with the naked eye. Once you see cleanliness level, you can monitor every 3 months or quarterly.
All right. I think that's some solid advice there. And I love the way that you presented the information in terms of letting us know exactly what you and the team did to try and
because
resolve
i
this
would
issue.
because I would say everything is a commercial impact. We don't want
Yep.
to make the life tedious for operator, because if we put every
Yeah.
test for short frequency, it is not means it not give something. It's a fancy that you have
Yeah.
every short frequency such test.
Mm-hmm. Yeah, because the operators, they're the ones out in the field every day and they will know
So
definitely if something's
quarterly,
going
you
on.
can say, which is recommended quarterly is fair enough.
Quarterly is fair enough for those bigger tests, those more I know those tests are slightly a little bit more expensive than your regular tests. So your advice is quarterly.
I think the line was disturbed. I was saying that on a very rational or balanced quarterly test is fair enough. Quarterly means every 3 months.
Yes, definitely. So that's a thank you for sharing that with us. And I don't see any other questions from the audience, but I wanted to, just
One thing which I miss, I have to add, if the turbine is undergoing in a peaking, because in
uh-huh.
Saudi Arab, Alhamdulillah, we are greatly here. Because of the petrodollar or something, there is no
Yes.
peaking because it's a steady operation. But if there is a peaking, that turbine going high and low, then there are some other frequency of some of the tests you need to revise.
Yes, definitely. And I know Yo is just coming in and he's saying for your steam turbines, steam and gas turbines, ASTM D4378, ASTM D4378 will give some additional information on your sampling frequency and recommended tests. Thanks for that, Yo. Thanks for joining in on that. So I think that's a good question as well. Good content. Um, the stuff that you spoke about in terms of trying to identify how you all have like a root cause analysis and going through that process, how would you advise somebody else who is having a similar issue? What is the first thing that they should do if they have something like that occurring on their plant?
See, Sania, understand when we received this first sample set in July 2010, then it was a very means severe to us. What was the reason? I
Mhm.
visited multiple times. I'm not means supposed to disclose the site here. It is a big power plant in
Yes.
central region. And but once we went with the GE team and we both work together and we achieve this thing, then it is a breakthrough.
Mhm.
Even if I have authority or something, we can do some MS or PhDs on this subject.
Right.
This back simulation of this thing in blue color in the lab is something very is high tech, I should say,
Mm-hmm.
because
And
we not find a copper. I forget to share this report in the used oil. Once
mm-hmm.
color in the lab, if people find, then people think copper sulfate or copper because copper is being used in some of the
Yes.
bearing or alloys in the metal. I'm not fully aware about the metal chemistry of all the parts, but the copper was zero. So we were more means bothered that why it is bluish, you know.
Yes.
Yeah,
It's a strange color. It's a good color, but it's a strange
yeah.
color. Yeah, and I have one person, Jed, is just asking, what would you recommend for varnish removal techniques?
See, okay, here my answer is something because all this world is finite. We cannot say, sometimes some people say life fill, but I do not believe. You can elongate this life of the turbine oil up to some extent.
Mm-hmm.
It is one of the reasons the celebrities are drinking the orange juices.
Oh my gosh.
Yeah, the orange juices having a natural oxidant, which is
Mm-hmm.
affecting directly on the skin and some of the aging process, slow down the aging process. Yeah, just for your information. So same thing in the turbine oil, we are adding antioxidant. So for free radical like oxygen, nitrogen, it will react and it will not allow to react with the lubricant molecule. So
Right.
lubricant will do but it can only extend up to some time. Once
Mm-hmm.
the varnish is produced, nowadays there are people, we do have that equipment is called, one company I'm not promoting is a Danish company, CJC. They have a kidneys filter and they are doing in some tank in isolation circuit, fix this equipment and they remove this varnish. Same like a dilation for the human. How do you do it?
Mm-hmm.
So this is the one of the varnish, but you cannot do anything by chemically to stop this.
Okay.
You need to replace the oil in a shutdown.
And we have one question from John. He's saying that They usually advise a routine monthly RPVOT, MPC, ruler, the multiplication for steam turbines, either 4 to 6 months. Do you think that time is sufficient?
For me, since we bought this ruler equipment from your company, Flutech, we are heavily using this thing, and we are measuring the peak area
Uh,
because
yes.
peak voltammetry principle at a certain time it coming. We knows our turbine oil supply to which customer having
Mm-hmm.
which additive. So we return sample in the lab, and once the used oil sample come to the lab, we compare with our original sample by
Uh,
superimposing the spectra, same like IR or something. So we knows this thing. So my answer here would be 4 months.
Okay. All right. That sounds good. And I think it really depends on the criticality of your equipment and what you're trying to monitor. Definitely, if it's critical equipment, you want to make sure you monitor that as much as possible. If it's not as critical, you may have like a little more leeway to work with. But I think we are almost at our end time for your session, Dr. Abid. I am so grateful for you for sharing your information with us. You are a wealth of information. Anybody that wants to connect with Dr. Abed, you can do that via LinkedIn. Um, Check him out. Definitely, these videos will be going up on YouTube. So, whatever you missed, you can go and get a replay of it. So, Dr. Abed, I want to thank you so much for your time this morning. We're going to get ready for Angus in another 5 to 10 minutes. We will be seeing him coming in with his presentation. So, be sure to join us. We're going to take a quick 10-minute break and then we're going to come back with another speaker. So, Dr. Abid, thank you again. And
So
for our
thank you, Sania. So thank
audience,
you, Sania, for
you
you
are
and for your team also from
you're
my
most
side, from my
welcome.
management. Thank
Most
you.
welcome. All right.
Bye
So
bye.
we'll see you all in a little bit.